Let's take a look at Fleet Baseline in ET Ducky. Fleet Baseline learns what normal looks like for every application you run. Right now, it's profiling 51 applications across 214 agents, drawn from nearly 500,000 observations of real activity. Each application gets its own baseline, built automatically, with no rules to write. Chrome alone has 28,000 observations behind it from 198 of your own machines, so the profile reflects how your environment actually runs. Here is what ET Ducky learned as normal for Chrome. It records the child processes each app spawns, and for Chrome that is only its own renderer processes and the crash handler, and nothing else. It also learns the ports each app opens and the destinations it reaches. Chrome talks out over ports 443 and 80 to web destinations, and it resolves names over port 53, and that is the whole pattern. And it captures the files an app touches, the privileges it uses, and its resource footprint. Chrome reads and writes inside its own profile folder, runs as a standard user, and sits between 2 and 9% CPU. Now here is a copy of Chrome that stopped matching. On the machine MKTG Workstation 22, this one Chrome process is behaving unlike Chrome on every other agent in your fleet. Look at what diverged. This copy spawned command prompt and PowerShell, something Chrome has never done anywhere else. It opened an outbound connection to a raw IP address on port 8080. It wrote an executable into the temp folder, and it spiked to 74% CPU. And ET Ducky is confident about it. The baseline was learned over 34 days across 198 agents, so this divergence lands at 96% confidence, flagged 11 minutes ago. This is the reference that powers detection. When you turn on Fleet Baseline Deviation under Security, a drift like this one raises an alert, and it can fire the app behavior deviation automation on its own. So that's Fleet Baseline and ET Ducky. It learns what normal is so it can catch what isn't,